Hey, this is Steven from LegitTechTutorials, and welcome back to my product development series. We are back working on the phone-controlled micro RC receiver project. Excuse me. I just wanted to point out that I wanted to push this project forward because I would like to have some of them built before Flight Fest West. It is a large event put on by Flight Test, which is a company that builds their own. They do YouTube content, different types of YouTube content, but they are originally they were the designers of foam-built airplanes. Well, first they did reviews on YouTube, and now they're known for building Dollar Tree foam board airplanes, RC airplanes. And so I signed up as a volunteer, so it's in Fairgrounds, Vallejo, 900 Fairgrounds Drive, Vallejo, California. And it's April 27th to April 30th, so I would like to have maybe a prototype there, 2 of them, and fly it around, see what people think, get some feedback, maybe get some buzz started on it. So I would like to at least get something in my hand and something in the air by then, and so we are pushing this project forward. Alright, so do not mind the wind going on outside. Hopefully it doesn't knock the power lines out. We're getting what does it say, 25 to 35 mile-an-hour winds with 45 mile-an-hour gusts. Storm coming through here. So I was thinking of doing some videos. So I was writing in here our prototypes needed, parts needed. So I've been talking about a few different things. In our last video, we were going over the parts for the daughter board and the different configurations. So now I wanted to go with the actual prototype parts needed for Flight Fest West, and just to get a basic proof of concept down. One is I found out what I needed for the power to power the motor, and those are what are called MOSFETs, which are a specific type of transistors. There's many types of transistors. I believe those specific MOSFETs are N channels, so those are called power transistor MOSFETs, and those are what they use in dual H bridges and stuff like that to power electric motors and whatnot. So yeah, a MOSFET power transistor for the brush motor, and that will probably be bought locally, definitely not from China, because we can't get it in here in time for the Flight Fest. So we're gonna need one of those for the brush motor for the brush motor. And then also we have a few other things that I wanted to show you, that I have a few tabs up at the top open looking at. Then we need a battery protection diode. So basically that prevents any sort of EMF or whatever from the motor making it back in towards the battery. And especially when we power off and the propeller is turning, we're not building a wind turbine here, so we don't want to have any sort of backfeed and mess up our battery. So then we might also need a transistor for a magnetic actuator. We'll talk about this in a second. I'll show you guys some Ohm's law on some of the magnetic actuators I have open up here in tabs. Then we're definitely going to need a 3.3 volt regulator, so we could run 4 volt power, or we could run 1 cell power or 2 cell power. Most of the time the brush power packs are only going to take 1 cell, and also the more cells we have, the harder the 3.3 volt regulator has to work. And also if we're using anything like the different sort of actuators for the back of the plane or wherever, you're going to need to also regulate those down. I don't know how well those would work if you have that high of power. And so some of the specs I was thinking about for the prototype, the 3.3 volt regulator is mainly for the ESP8266, as the ESP8266 is
is very strict. 3.3 does not have a voltage regulator on board, so have to give it 3.3. Go a little higher, but you don't want to blow it out. For the first configuration, what I'm thinking of doing is two-channel rudder and throttle. So standard two-channel. Then we have Wi-Fi using the ESP8266 and using a small brushed motor or a geared brush motor. I might go with the geared brush motor. I just got 3 brushed motors geared in the mail, and one's an 8.5 millimeter can. That's a little big for a really small plane if I was using a linear actuator, but even if that's the case, I mean, we could also build our own linear actuator. I'm going to go over the linear actuator here in a second. But what I'm thinking is that it's going to be a servo, and I'll tell you why. The main issue that I was talking about in other videos is that the linear actuator is difficult as far as a circuit setup, because you need to have, in order to change the rudder from going to the left, from deflecting to the left to deflecting to the right, you have to move the magnet to the different side, right? You have to repulse one side while attracting the other, and then if you want to go the other way, you flip it. Now you're attracting to the side that you were originally repulsing, and you're repulsing the side that you were originally attracting. Now to do that, you have 2 wires, and using 2 wires coming out of the actuator, right? Basically you're just feeding the current an opposite way through the magnet. So you would need a pretty elaborate transistor network, generally like a dual H bridge or a single H bridge, where you could change the direction, right? But a single H bridge, it uses 3 pins. It uses PWM speed control, a pin for one direction of speed, and a pin for another direction of speed, right? Which generally is for motors, but with this it would be to alternate which direction the current goes through, which is how it controls the motor direction, is by alternating the way the current goes through. So the issue with that uses 3 pins, and we only have 4. So sure, it would work that now you only have one extra pin left, right? I mean, now you have 1 extra pin after the dual H bridge, and then that's for your motor. Like, what if you want to have more? What if you want to have more magnetic actuators? You know. So the ideal would be that you have a driving pin, or some sort of separation. The idea is if you only drive it with 1 pin, and then you could drive it from the power supply, right, from the battery. So just have 1 signal come off of the ESP8266 that would drive it, and have it drive similar to like a servo, right? And so I came across these. Let's go ahead and take a look at the magnetic actuators if you've never seen one. So here's and this is on AliExpress, and they have all different types of sizes. So generally how servos are measured is they're measured in the weight of the servo. And so these, and also they sometimes give size of servos, but generally there's no magnetic actuator size. It generally talks about the weight of the magnetic actuator. And you can see how small that is. But basically what's going on in there is you have this little flap, and then at the bottom you have a magnet, and when you magnetize one direction, it creates a magnetic field that will go like a spiral above the top. And depending on which way the current goes through either of these 2 wires will determine which way it deflects. And also the PWM that you send into whatever transistor would also affect how much precision you get and what current course it's on. Another thing that I wanted to show you guys is let's take a look at some more. So here are like 0.3 gram, and then you have the really low, which is 0.12 gram, 0.28 gram, 0.68 gram. Yeah, so what are my simple ideas for it to get it to work? And I believe this is all sold by the same company.
Hands magic, hands magic, hands magic. Yep, they're all sold, but see, only one particular company makes it. So you see they're all $5 with free shipping. Anyways, so one of the ideas that I had was to what I call bias the linear actuator, the magnetic actuator, which is basically to put a spring onto that arm, and basically when power's off, it's clamped to one side. It's biased. It starts out at one side, or if you can think about a regular servo on an RC plane, it's trimmed all the way out to one side. Then as you add power, or you add the PWM signal, right, it begins to move the, and now you only need to do, and I'll explain that in a second. So now all you have to do is add power, and it will move it from that left bottom outside all the way to the other side. But of course, as it goes through its entire range of motion, that spring is resisting that motion of F equals kx. So the force of the spring is equal to the spring constant times how far you get away. So linearly, the spring is resisting the movement. So you're drawing more and more and more current as you go farther and farther away. But that way, you use only one pin. But even if the linear actuator is in the center, you are using quite a bit of power, right? Just to hold it steady, just because basically the magnetic actuator is compensating for that spring. But you only use one pin because the current's only going through one way. You don't need the current to go the opposite way to turn it left or turn right or whatever, because it's already biased to that side. So it starts out full right, and then depending on the PWM signal you put in, it will move to the center or further to the left, or maybe really close to the right. You know, it starts to get further and further away. Now it's in the center, further away, closer and closer to the left. Now it's all the way to the left. So that's one way of doing it. That's a simpler way, simple and dirty way, but it's going to be not very efficient because you're going to, pull a lot of juice in order to get it to do what you want. Another thing that I wanted to show you guys is the current draw on one of these. So generally it tells you, there you go, 100 ohms. So if you guys are not familiar with Ohm's law, which is V equals IR, which is, a simple oversimplification, right? Because once you put current through that wire, resistance increases with heat, blah, blah, blah. But it's an ideal situation. So V equals IR, we're curious about I, the current. So V is voltage, I is current, R is resistance. So we're curious about what type of current we're going to pull on that. So we have a voltage of maximum of 4.2 volts on one cell, and that's max charged. That's the worst case scenario. Or the highest current it'll ever draw, I guess, technically. Yes. So you're going to have 4.2, and then we're going to divide it by how many ohms of resistance, a maximum of 100 ohms. So that's a maximum of 0.042 amps, or 42 milliamps. So 42 milliamps is actually inside, I believe it's inside the realm of what the ESP8266 could put out. The ESP8266-01, I believe, could even do that. So that is, and as the voltage decreases, that decreases, right? But if this is spring-loaded, where I basically have a spring attached to here and it's grabbing this arm and pushing it to where it's hitting here, you're not going to get, it's definitely going to be a lot more than that current, because all the force reacting with it. But I just wanted to show you guys that type of calculation and show you guys what type of current we're talking about. Most of these are pretty close. Here's like 105 ohm. And of course, the bigger you get, generally the bigger you get, the bigger the wire, the bigger the winding, right? So maybe if we found like a, see, here's like a 200 ohm. Right. And basically, the higher the ohms, the lower the current, but you're going to get more magnetic, more magnetic field because there's more windings. But these are really tightly wound. It's very nice. Okay, but of course we could 3D print something like that. That would work just as well. Okay, so another thing that I found was pretty interesting. When I was going through this, I saw this. I was like, ooh, there's a PCB here. And I opened it up, and it says electromagnetic actuator conversion board. And actually what it says it is you actually put it's actually a conversion for your standard receiver to go from servo to linear actuator. So you put in your plus and your minus off of your battery, and then you put your signal off of your receiver. In this case, the ESP8266 or some other receiver that you have, right? So this would basically be, you take your servo line, your servo line, cut it, and then your servo line has a plus, a minus, and a signal. So it's the same exact thing as using a servo line, except for you're using this board instead. And it has a curious IC on the back that controls it all. So, and then on the front it has a resistor, and I think this is a diode, or either or, and then here's a LED that tells you that the signal's coming in. And then you basically attach the electromagnets here. And then probably in your controller you just flip if you put it in the wrong direction. But with these pictures I cannot see what that image says. So I might go on to, blow it up inside Photoshop or whatever, and then try to upsample it and see if I could pull what the ID says on the front of that. But if that doesn't work out, then I can just ask them. In worst case scenario, if they don't want to tell me, I just buy it and then I can see it then. But I like how it's got free shipping with the e-packet starting out. But I would need it to come in pretty quick. It would have to be like, that one's too long. It would have to be like this one or something. So I'll ask them and see if they get back to me within a decent time, because these guys look like they're pretty cool, because they got a whole bunch of linear actuators, especially this one, which is super cool. 0.12 grams, and then the weight is 0.2 grams. So it would be nice just to find that IC, and that IC will take care of all those issues. Don't need to use a spring, and very good, very efficient. But it says here that it uses static power consumption 1 milliamp, maximum power consumption 10 milliamps. So 10 milliamps extra, so that's 50 milliamps, right? Even though your piece would use 40, now it's using additional 10 milliamps. But this should also be good even for a larger linear actuator. So let me show you guys what I'm thinking about for the servo. So we're on Hobby King, and I'm gonna go servos, sub micro servos, and then I'm gonna go by weight, and so we have 3.7 grams, 2 grams, 4.3 grams, 4.7 grams, 2.2 grams, 2.2 grams, 1.7 gram, 1.9 gram, 2.2 gram. And then these are the ones that that are the more common ones. 1.7 gram linear actuator. So you could build you could build a 3D, you could build a profile style plane and still have this guy stick out. This guy would probably be a little bit better for a profile plane, which is probably what I'm going to do. But I don't think I could even find any one on here that's less than 1.7 grams, right? But these guys, this one's all the way down to 0.12 grams. So past the 0.12 1 7-gram, you're not going to find anything smaller than that, generally speaking. So if you want to go any lower than that, you're going to have to go with a linear actuator, which would be nice to have the support for that built into the board. So we could either build a custom one and then have it spring biased as a prototype, which at Flight Fest I could even wind one and just buy a small small neodymium magnet at Fry's or Radio Shack down there, or up there technically. It's north of me. But off the bat, this guy will probably be a good start. And even these get a lot of torque, so even with this, I think it would be okay. But these don't even show, I don't think, the torque they have. Oh, it does, 80 grams. That's a lot. For how small that is. And then here's another one. Okay, so what do we got? Torque at 4.2 volts. It is so basically 75 grams. So this is way more powerful than the other one, right? So this one is, oh no, this is 80 grams. Okay, so yeah, this one's more powerful by a little bit. This one's slightly less powerful. Interesting. This one's 449, and the other question is the throw. As most of these are like 60 degrees. These are like 60 degrees. Yeah, 60 degrees generally. 60 degrees either way, so basically 120 degree sweep. I don't know why it's not letting me bring up the picture. Anyways, yeah, so something like this, something with very low current draw. But even though it's very low current draw, we're not going to be using the power out of the ESP8266 anyways, so this should be working fine for us. But the smaller and smaller we go, you know, we're going to have to go with the linear actuators, right? Because what do we have already? The ESP8266 is 1.5 grams, or 1 gram if you get rid of the pins. It's probably like 1 gram, 0.6 gram. And then you got this guy, which is 1.7 gram. So let's say 2.5 gram. And then that's already past, some of the world record ones are like 1.5 gram. And then the battery you're talking about is like 4 grams. So this is pretty good around the battery size that we're going with, because it's pretty hard to find something lower than 150. I think it's pretty difficult. 150 is generally what you go for, so that's 4 grams. So this should be good for a plane like that you want to fly in high wind situations a little faster than normal. So this guy should work perfectly fine. So something like this, but the issue is, of course, it's shipping from EU, so it's probably not gonna be. I wish it would tell you where it would be shipping from. And then this one down here, shipping definitely from China. So we might have to go with this one. Ooh, this is global. I probably won't even do that one. I'd probably find one that's local. Yeah, see the motor sticking out of the bottom. Yeah, from Hong Kong. $3. 14 to 39 days. I think it could. So yeah, I'll have to find something that will work with what we're looking for, and then probably I might even try to find those JST connectors, so you can just connect those guys in there, and then cut it off. Another one is I could also stick a JR connector on there, and with the JR connector, generally I think has 0.1 millimeter. Yeah, see, this is micro JST 1.25 millimeter pitch, which is not the same as what you get in a perf board. The perf board is what you use to prototype out electronics. So the JR has a 0.1 millimeter, so JRs could stick right onto a perf board or into an Arduino, right? So these ones will not, so I might even cut that off, put a JR connector on there, so you can easily plug in and unplug these out of the board, so you could plug in a linear actuator or whatever. And then in the meantime, I'm either gonna build one, because most of them are far out for China, or build one and then bias it with a spring, and maybe I might find something like that IC, and then build some sort of janky setup, kind of like he's got with SMD, because that's a surface mount component, looks like. So maybe do a beginning of PCB with that. But those are my basic thoughts as of now, as far as what we're going to do for this first prototype, which will be coming up here pretty quick. I'll probably be ordering these parts this weekend, and so with that we will be moving on, and then we'll do some soldering and stuff, and the other room is still being worked on, so I don't quite have somewhere to solder or whatnot. But Tech Shop just reopened, and their new location is pretty sick, and they actually have a little thing downstairs called the Maker Cage. And in the Maker Cage, you could they have a whole bunch of what they call maker cages, which are basically chain link fence cages that are about 10 feet wide by 15 feet long, and you could rent those and have assembly area, right? So I might get one of those, so I'll have a little place that I'll always have to go down there and do some soldering. Maybe not record audio, but solder it with the audio muted, because it's a chain link fence. When people are down there, and there's really low ceilings, so when people are down there, you're gonna hear it. But that's the idea. Hobby King Ultra Micro Servo, and then use either a geared or just a regular brushed motor, or I could just take that brushed motor off of the other one, stick a prop on it temporarily. I have some props for I have some of those little circular props for the what is it called? 30B F36, the little quad. It's a Chinese knockoff of the Inductrix, the blade Inductrix. So I have some of those 4-bladed props that go into those ducts. So I could stick that on that 8.5 millimeter can motor instead of using the big, huge 5.5 inch prop. But we'll see what happens. And I'm also going to need to find some very lightweight material, which will probably either be some sort of packing material, or maybe like some thin Depron. And I will be getting access back to Tech Shop's laser, so I will be able to laser out some stuff if I need some, if it's thick and I need some exact stuff. But what I'm thinking is to do a profile plane, a really nice thin profile plane with 2-channel, just power and rudder, and then do the code for that. And also, what I forgot to mention is I was going around one of the, because from this video I'm going to say right now that if you guys are electronics experts, I'm not, so some of these things could be wrong. It's kind of my first thing, my first electronics build, this and the other video, which is the smart charger
So I'm learning, while hopefully you guys are learning as well, as the point of these videos are to inspire people to go out and start projects like this, make mistakes, spend a little money here and there, design it virtually before you spend any money, do the research, blah blah blah, and then talk about how I did the research, etc. So, but of course, just like in this video, just like you'll have it, mistakes happen. So I'm just showing you guys everything that happens, so if mistakes do happen to you guys, you're not discouraged and you keep going. So I was looking through and I saw 123D Designs from Autodesk has an ESP8266 emulator that's in beta, as well as a MOSFET, as well as a mini servo. So what I might be able to do is code it from there and to mess around with it to show you guys before I build a prototype. So that might be what I'll do in the next video, try to prototype it from there. I've never really worked with the ESP8266, and also I need to have a programmer sent in because I don't have a programmer for it yet. I don't have a FTDI programmer yet for it, so I can't program it anyways. But I can program it virtually in 123D Designs while I'm waiting till next week. During the week to get a programmer in for it. Otherwise, yeah, so that's sort of what I was showing you guys. If you're going to go smaller, of course you're going to go smaller motor, smaller battery, and you're going to go with a linear actuator. So I'll get into contact with that company to figure out what that IC is so we can get moving further on the magnetic actuator, to figure out what that one IC is, because having one pin control would be great. Alright, so that is basically it. Next video you should be seeing what I purchased for the project, and also we'll go onto the schematic and start building with the 123D Designs ESP8266. And we'll start designing it. And then maybe from there you can even buy those boards made, so maybe I'll even be able to set up some stuff, some through pins, where I could get some boards that are assembled and they'll come in and we can assemble it. But as of right now it's going to mainly be built with perf board, but maybe we can go right from 123D Designs. And then I might even take the one of my buddies Nolan at Tech Shop, he teaches the EagleCAD. The EagleCAD, Autodesk Eagle, which is PCB layout design CAD. So maybe I'll even take the class so that you could even import your CAD design from 123D Designs into EagleCAD. But I don't believe EagleCAD has any of those programming stuff. I believe they only have simulations, and I don't know how deep the simulations go. Alright, so with that, that is basically it. I've gone over pretty much everything that I wanted to go over. I will see you guys in the next video. I'll thank you guys for watching. If you like this video, please subscribe for more videos like in this series and other series as well. Thank you guys for watching. I'll see you guys next video. Take it easy. Peace.